Welcome back to Further Solutions Academy. Further Solutions Academy. Further Solutions Academy. Encourage us more to share our video and subscribe. If you have not subscribed before, kindly press on your subscribe button. At this point, we have a lot of videos for you to work with. Mathematics, physics, chemistry. Over 400 videos. You can come here and learn any topic of your choice: mathematics, physics, and chemistry. Okay, just in case you want to reach us, you can make use of this line to reach us. With this line, you can call us, you can WhatsApp us, and Telegram is allowed. That will be three. Okay, please, any of our video you watch, kindly comment on it for moderation. On this video, being on topology, it's a one course in mathematics, in advanced mathematics, which is under set theory. Now, I'll be talking about the interior, exterior, and boundary of a topology, of a topological space, anyhow you want to call it. That is what I will be working on. By the end of this video, it means the video outline of interior, exterior, and boundary of the topological space. That is what I'll be working on. By the end of this video, you understand these three things. Okay, if I should give you the definition of interior, look at the definition. Okay, look at this. Let's talk about the definition of interior after definition of exterior and definition of boundary. After that, I will now give example that will illustrate that, and it's okay, you are good to go. Let A be a subset of a topological space X. The interior of an A denoted by what? This is interior of A. This is how it's already denoted. Denoted by A is the union of all open sets containing A. Is the all union of, I've explained open sets. If you don't have problem, if you have problem with open sets, please try to understand open sets. How do I say about open sets? Open sets are open sets when they are in what? In tau of A. Just notice that. That is what I mean by open sets. We have video on open sets. Note, remember that the closure of A is denoted by what? By this, which we just finished that in our previous video, is the intersection of all closed sets containing A. Is it now clearly that the interior A is open and subset of A, and the closure of A is closed and contain A. This is the real what I've been telling you. That is all what I mean by that about what is the name of this thing? Interior. About definition of interior. That is interior. Now, let me talk about the exterior. Now, let me quickly talk about exterior. With the help of example, you understand it clearly. Now, let's talk about the definition of exterior. Exterior. Okay, look at definition of exterior and boundary. Now, exterior definition: the exterior of A denoted by, this is the exterior, is given as interior prime, is given by interior prime. That is to say, exterior equals to interior complement. That is the complement, and I've explained what is called complement of a given set before. Definition of boundary. Boundary of A is the set of all points that do not belong to the interior or exterior of A. That is what I might mean by what? That it does not belong. That do not belong. Belong to. Now with this, let me go for example. Let me try to show example. With the help of example, you will understand interior, exterior, and boundary points very well. Now let's go for example. Now look at the example. Now look at this question. I have S as this, and I have T, which is tau topology, as S, this, and I have my A as that. Oh, sorry, I made a mistake. This can never be A. This is small letter A. Now I have my A as that, even though it's supposed to be B. Let me put B there. Okay, B. Now I have my this as that. You are asked to find interior of A, B exterior of A, E, which is 1 Roman figure 2 Roman figure 3 boundary of A. Now by the end of, after solving this thing, you will understand interior, exterior, and boundary very well. Now let's see how it will go. Now, solution to this problem. The first thing I need to find is number one. We are talking about what? Interior of A. Now we need to find A by, what is our A to be? What's our BA? Our A is equals to B, C, and D. That is my A. Okay. Now we have to check for some things here. The first thing we need to check for, we need to check for the we need to check and find out which of them will be interior of A. Which of them will be interior of A? It means the first thing is that let me just first pick up B. Now taking B, okay, for B, let's start from B. Now what can we say about B? Open set containing B, open set that contain B. This is the open set I'm talking about. Sorry, here is the open set. Now among the open set, which of them that contain B? Now the one that contain B is just B, C, D, E. B, C, D, E. That is the only one that contain B. Now among that, what I will now do next is that okay, any of okay, after that I will note that any of them that subset of A, it means is a subset of A. Can we say is a subset of A? This is it a subset of A? Can we say is a subset of A? What I'm saying there is that this is not a subset of what? This is not a subset of A. Since it's not a subset of A, now it means since it is not a subset of A, it means B is not. It means B is not interior of what? Of A. B is not what? Interior of A. That is what I mean by that. B is not interior of what? Of A. Now I will move on to the next one. Now it means taking B with what I've said now. B is not interior. B is not interior. Now I will now write here B is not interior of A. B is not interior of A. I will go and take the next one in that A, which it will be I'll be taking C this time around. Now for C, now this is C. For C, I'll move on by having all open sets that contain C. All open sets that contain C. Normally X A, then S supposed to be there, but if I do the same thing for S, it won't be on that. Now all open sets that contain C, it means open sets that contain C are, I will be having C. I mean X himself. S is containing C. What else? It also contains C. I have CD. It contains C. I have C, CD. It's containing C. I also have B, C, D, E. It's also in that C. Now, since that is the case, I will now say that what? Look at this. My first one for X, Okay, let me neglect S. Let me move on to this one. For CD, is it a subset of A? C, is it a subset of A? D, is it a subset of A? Yes, it's a subset of A. Because CD is in A. CD is in what? Is in A. Therefore, it's correct. I'll move on to the next one. CD is in A. Can we move on to the next one? Okay. Is that okay? Look at this one. ABC. Normally, CD is also in A. If I say this is also in A, it means I will now say that what? C is interior of what? A. C is the interior of what? Of A. I will move on to the next one. Taking D. I want to take D. D now. For D, I will say I will do the same thing. The open set that contain D. The open set that contain D are X, CD, ACD, and BCDE. Now, that is my open set that contain D. Now, look at the first one. I have to take the list of them, which is the list. This is the list of them. Among this is the list. CD. CD is in A. Is in A. Okay. CD is in A. Yes. If CD is in A, it means hence D is interior of what? A. D is interior of what? Of A. That is all about that. It means interior of A. Now, interior of A equals to what? CD. Interior of A is CD. Now, what I need to do now, it means what? D is interior of A. D is interior of A. Now, among these things, I will not list them out, which is my set A. We have we have B, C, D. Now, what I'll just do, this one is not interior, this one is interior. It means the interior are what? Hence, interior and CD. Interior and CD. Now, I'm done with that interior. Now, let me go to exterior point. That is number 2. Exterior. Now, I'm now on exterior. Now, this is interior. Please take note of this. This is interior. These are interior. I don't need all this thing for the space purpose because my body is very small. Sorry about that. Now, look at exterior, number 2. Exterior of A. The first thing I will do is that, note that, I don't know what I explained to you that time, that my exterior of A equals to what? Interior prime of A. That is what I mean to do that. It means since my A equals to B, C, D. Now, my prime of this will be equals to X minus what? A. X minus A. I think we all know that any exterior, okay, by having this, it means I can say that with this statement, I can easily say that what is my X? My X is A, B, C, D, E. Now, minus B, C, D. minus BCD. Now, it means my A prime will be equals to A BCDE. That is my A prime. That is my A prime. Now, I want to check for A. Let me check for A. Now, I think for A now, because I'm taking this first. Now, all open sets containing A are S himself, A, we have A, we have C, and that's all. These are the things that contain in A. These are the things that contain in A. Another one, that is all. That is all. Now, the one that contains is this one. Now, what I will just do now is that you can see that my A, set A is in A prime, very correct. Set A is in A prime, which is the list. Set A is in A prime, hence A is exterior of A. Because set A is what? You pick up the list of them, which is, this is the least among the three. 1, 2, 3. This is the smallest one. It means the cardinality is 1. Cardinality of this one is 3. This one is cardinality of this one is 5. It means of that one, the least of it, if you can check that is in the prime of that A, it means is an exterior of what? Of A. Let me quickly move on to the next thing that I want to explain there. And now let me take for taking E now. I want to take E. Now let's make take E. I want to take my E. Now all open sets containing E, I have X, I have B, C, D, E. These are the open sets containing E. Now, since I have that, I will now look around and check among these things which one is a subset of that A. So what can I do? Now, okay, now if I should do this very well, I can see that this is not, you can see that the list is B, C, D, E. Is not a what? Is not in E. Since it's not in A, it means E is not exterior point of what? Of A. Is not an exterior point of A. It means if I should conclude my okay, if I should conclude my exterior of A is only A. That is my exterior point of A. Now the last of the thing is the boundary, which is the third one. Now, how do I go for my boundary? Boundary of A. It means note that X is equals to A, B, C, D, E. That is my A. Now, interior of that A is CD, and exterior of A is only set A, singleton set. Now, since I have that, I will now come to this X. I will have my A, B, C, D, E. Now, look at this. This one is exterior of A. This one is interior of A, and this also an interior of A. Now, the remaining one are Now, hence, boundary are equals to, boundary of A will be equals to B and E. Boundary of A is equals to B and E. You can see how to generate interior, boundary, and exterior. I'll be stopping here. Don't forget you are home with Further Solutions Academy. Once again, thanks for watching.